Good day, students, and today we'll be looking at some questions in physics that you might likely see in JAMB next year. So the first question here says, the stress experienced by a wire of diameter, so we're given the diameter in this question as y over pi meters. Loaded by a weight of, so we're given the weight, which is a force, as y squared Newton. So we are going to find the stress in the question. So stress, know that stress is force over area. So the first thing we have to do is to find the area, since we already know the force. And we know that area of this is supposed to give us pi r squared. And since we do not know the radius, we know that radius is supposed to be diameter divided by 2. This means that my radius is y over 2 pi. So if you impute this, it means that my stress is supposed to give me y squared divided by pi times y over 2 pi all squared. So this will give me y squared divided by pi y squared over 4 pi squared. So we have y squared divided by pi y squared over 4 pi squared. This will give me that I have y squared times 4 pi squared over pi y squared. So y squared will cancel y squared. It means that I have 4 pi squared. So pi here will cancel out this square. So I have 4 pi. And this will give me my final answer. And if you look at our option here, what we have there is option C, which says what? 4 pi Newton per meter squared. Moving on to question number 2. Question number 2 says, under which condition is work done? First option here says, a man supports a heavy load on his head with hands. Option B says, a woman holds a pot of water. Option C says, a boy climbs onto a table. Option D says, a man pushes against a stationary petrol tanker. Now, for work to be done, there must be a displacement caused by the force applied. So, in which of these can you see that there's a displacement? And that is option C. When a boy climbs onto a table, he's applying a force to climb onto the table. So, he has moved a distance. But in option A and option C and B, there is no movement. And hence, option C here is the correct answer. Moving on to question number 3. Question number 3 says, we have a diagram there. If you look, there's a diagram. The diagram ought to be beneath the question. So that's a typographical error. So we have a diagram there, and it says, the mechanical advantage of the machine shown is dash. So this diagram here, you discover that what? We have an inclined plane, and this inclined plane has a height and has a length. And whenever you have an inclined plane like this and you are looking for the mechanical advantage, your MA in this inclined plane is the height over the length. So in this case, what we are going to be having is 15 centimeters divided by 0.5 centimeters, and that will give me 30.0. And that is my final answer, which is option C. Moving on to the next question, which is question number 4, it says, rainbow is formed when sunlight undergoes dash. Now, when light is incidented on any surface, it's going to undergo reflection, refraction, diffraction, and dispersion. But in this case, when rainbow is formed, it means you're having many colors of light, and that is happening when there's a dispersion of light. So that is option C. So rainbow is formed when there's a dispersion of sunlight, which is option C. Moving on to question number 5, it says, find the value of a capacitor with voltage 5 volts and 30 coulombs. So we have the voltage of this capacitor, the voltage as 5 volts, and we have the quantity of charge as 30 coulombs. And we know that the capacitance is unknown because we have to find the value of the capacitor, which means that the capacitance. So, and we know from our formula that what? Q is equals to CV. This means that my C is equals to Q over V. And this means that the capacitance is equal to 30 divided by 5. and that will give me 6 farad. 6 farad. And that is option B. Moving on to question number 6. It said, when a bus is accelerating, it must be dash. A, it must be changing its speed. B, it must be changing its velocity. C, it must be changing its position. And D, it must be changing its direction. Now, from the definition of acceleration, you can easily answer this question because acceleration is simply the rate of change of velocity. So, whenever a bus is accelerating, it must be changing its velocity. So, the correct answer to this question is option B. So that takes us to question number 7, which says that the friction due to air mass can be reduced by dash. The friction due to air mass can be reduced by that. What do they mean? Whenever a body is floating in the air, how do you reduce the friction? If you are running, you discover that there's a force that is pushing you backward. So how do you reduce that force that is pushing you backward? That's friction due to air mass. So while you're running or while something is flying in the air, there's a force that is resisting the forward movement of that body. So how do we reduce it? You reduce it by streamlining. That's why you discover that your airplanes have pointed ends. Even your ships have what? Pointed ends. That's what? Streamlining. So the correct answer to this question is option A, which is what? Streaming. That is also question number 8, which says, which of the following operates based on magnetic effect of electric current? Based on magnetic effect of electric current. Your electric heater uses electric energy and converts it to heat energy. Your photocell uses light and converts it to electrical energy. Your dynamo converts magnetic energy and convert or electromagnetic energy and convert it to electric energy. So which of the following operate based on magnetic effect of electric current? That is what? A dynamo, which is option C. A dynamo converts magnetic energy to electric energy. Question number 10. Question number 9, sorry. Question number 9 says, when a charged ebonite rod is brought near a charged glass rod, there will be dash. Now, when an ebonite rod is charged, it is usually negative. Ebonite rods are usually negative when charged. And when a glass rod is charged, it is positive. So when a positive charge meets with a negative charge, there's usually a force of attraction. So the correct answer to this question is that there will be a force of attraction, which is option A. Moving on to question number 10. Question number 10 says, pilots use aneroid barometer to know the height above sea level because of dash. Why do they use aneroid barometers? Aneroid barometers are very small and convenient. They are easy to use. So the reason why they use it is not because of accuracy, it's not because they are heavy and huge, it's not because they are costly, but because they are small and convenient. Hence, they use it in airplanes and aircraft generally. And the correct answer to that question is option B, because they are small and convenient. So question number 11 says, a light ray passing from air into water at an angle of 30 degrees from the normal in air would dash. What do they mean? We've talked about refraction. So if I have a normal, let's say this is air, this is air, and this is water. And a ray of light travels at 30 degrees to the normal. So I have 30 degrees here. This is my normal ray. So I have my incidental ray coming this way. So they are now asking what will happen to this ray of light while it is inside the water. So this is still my normal. Now, when this ray of light travels from air into water, you discover that what? There is a shift in the reflected ray towards the normal, thereby making the angle of reflection lower or less than 30 degrees. So instead of it to be as large as 30 degrees, because it has traveled from one medium to another, from a less dense medium to a denser medium, it is going to be reduced. So there will be reduction in the angle of what? Reflection, such that what? So if you look at our option here, it says, option A says it makes an angle greater than 30 in the water surface, which is wrong. B says it will be completely absorbed by the water surface, which is wrong. Option C says it will be completely reflected by the water surface, which is also wrong. And option D says to make an angle less than 30 from the normal in the water, which is what? Correct answer. So it's going to make an angle that is less than 30. So this angle here is going to be what? Less than 30 degrees with what? The normal in the water. Moving on to question number 12, it says a solid cube of aluminium is 1.5 centimeters on each side. So our side is 1.5 centimeters. Then it said the density of aluminium. So our density is given as 2,700 kilogram per meter cube. Say find the mass. So the mass is unknown. So, and we know that density is equals to mass over volume. So the first thing we're supposed to do is to find the volume, and our volume is going to be side cube, which will give me 1.5 times 1.5 times 1.5. For easier calculation, I'm just going to convert each one of these to be in centimeters instead of to be in meters instead of centimeters, and that will give me 15 over 1,000 times 15 over 1,000 times 15 over 1,000, and that will give me 3375 over. So if I divide, it means my volume is going to give me 3.375 times 10 raised to the power minus 6 meters cube. So I've gotten my volume. The next thing, I'm going to use this and input into the formula to get our mass. Since we already know what our density is, this means I'll be having 2,700. Since my formula says density is equals to mass over volume, it means I have what? 2,700 is equals to mass over 3.375 times 10 raised to the power minus 6. So if I cross multiply, it means that my mass is equals to 2,700 times 3.375 times 10 raised to the power minus 6. And that will give me 9.1125 times 10 raised to the power minus 3 kilogram. But if you look at our options are in grams. So in order to convert this to gram, I'll divide by 1,000, and that will give me 9.11 grams. So if you look at our option there, the correct answer to this question is option B. Moving on to question number 13, we have a diagram, and then the question says the value of R required to make the galvanometer measure voltage up to 40 volts in the diagram above is dash. Now looking at this question is based on shunt and multiplier. From the diagram you can even tell, because it is boldly written there, that this is a multiplier question. And what is the multiplier? A multiplier is a high resistance resistor connected in series with a galvanometer in order to convert it to a voltmeter. So what do we do? In the question, we are given the current as 20 milliampere. So we are going to convert this, and this will give me 20 divided by 1,000, which will give me 0.02 ampere. So with that, we're also given the internal resistance in the question as 10 ohms. And we're told that the galvanometer is meant to measure a total voltage or a total EMF of 40 volts. And we already established that the EMF or the total voltage in a circuit is equal to IR plus IR, which is same as saying the total EMF or the total voltage is I open bracket R plus R. So if I impute my values into this means that I have what? 40 is equal to, this will give me 0.02 in brackets. The multiplier there is unknown, so I have my R plus my internal resistance there is 10. So this will give me, I divide both sides by 0.02, divided by 0.02. This means that I have, this will give me 2000 is equals to R plus 10. If I collect like terms, it means my R is equals to 2000 minus 10, and that will give me that my R is equals to 1990 ohms. So looking at our option there, that is option B, 1990 ohms. Moving on to the next question, which is question number 14, says 5 times 10 raised to power minus 3 kilogram of a liquid at its boiling point is evaporated in 20 seconds by the heat generated by a resistor of 2 ohms when a current of 10 ampere is used. The specific latent heat of vaporization of the liquid is dash. So in this question, we are given the mass as 5 times 10 raised to power minus 3 kilogram. And we are given the time that they use for this particular resistor as 20 seconds. And then we're given the resistance of the resistor as 2 ohms. And we're given the current used by this resistor as 10 ampere. We're asked to find the specific latent heat of vaporization of this liquid. We do not know. So, and we know from what we already established on specific capacity and latent heat, that heat lost by this particular resistor must be equal to the heat gained by the liquid. And since the resistor is electric, it means that the work done in the resistor, which you already know that Q in this resistor is going to be I square RT. This is the formula. Since we have current, we have resistance, and we have the time. So this is the formula for calculating the work done in the resistance. So, and this is supposed to be equal to the amount of what? Heat that is what? Absorbed by this particular liquid. This means that I have what? I square RT is equals to ML. If I make L under the formula, this means that my L is equals to I square RT over M. This will give me that my L is equal to, so my I in this question is 10. If I square this is times, the resistance there is 2, and the time there is 20. This is divided by 5 times 10 raised to the power minus 3. So this will give me 100 times 2 times 20. So I have 4,000. This means that my L is 4,000 divided by 0.005. So that will give me that my L is 800,000, which is same as saying my L is 8 times 10 raised to the power 5 joules per kilogram. So looking at our option there, we're looking for 8 times 10 raised to the power 5, and that is option B, 8.0 times 10 raised to the power 5 joules per kilogram. Moving on to the next question, which is question number 15, it says, if the standard vapor pressure of water vapor was 13.5 millimeter mercury at 32 degrees Celsius and 7.3 millimeter mercury at 7 degrees Celsius, find the percentage relative of the air on a day when average air temperature was 33 degrees Celsius and dew point was 7 degrees Celsius. So for us to find our percentage relative, is going to give us our SVP in air over SVP in water times 100 over 1. So this means that my SVP in air is 7.3 millimeter mercury over my SVP in water is 13.5 millimeter mercury. This is times 100 over 1. So if you divide and multiply by 100, you're going to get, so I have 7.3 divided by 13.5, that will give me, times 100, I'll get 54.07%, which is equivalent to saying I have what? 54%. So looking at our option there, that is option C. Moving on to the next question, which is question number 16, it says electrolysis can be investigated using dash. A, we have the voltmeter, B, we have the ammeter, C, we have the galvanometer, and D, we have the voltameter. The voltmeter is for measuring voltage, the ammeter is for measuring current, the galvanometer is for measuring the direction of current, and can also be used for measuring the amount of current if you convert it using your shunt. You can also use to measure the amount of voltage you convert it using your multiplier. So the correct answer to this question is the voltameter. We use the voltameter. Example is the Uffman voltameter for measuring or investigating electrolysis. So the correct option here is option D. Moving on to the next question, it says a wheelbarrow is inclined at 60 degrees to the horizontal, is pushed. So we have our angle of inclination, theta, at 60 degrees, is pushed with a force 150 Newton. So the force here is 150 Newton. So what is the horizontal component of the applied force? The horizontal component we do not know. Horizontal component is F cos theta. So it means that my horizontal component here is going to give me 150 cos 60. And this will give me 150 times 1 over 2 because cos 60 is 1 over 2. That will give me 75 Newton. So my horizontal component here is 75 Newton, and that is option D. Moving on to the next question. Question number 18 says, in a solar panel, solar beam is concentrated by using dash. So when you say concentrated, it means we are bringing all the beam of light to a point, and we use what? A concave mirror. A concave mirror will concentrate the beam of light to a point, thereby generating an amount of heat that will be converted to electricity on a solar panel. So the correct answer here is option A, which talks about what? A concave mirror. Question number 19 says, a rectifier is a device that changes dash. A rectifier is a device that converts AC to DC. It converts AC to DC, thereby ensuring that what current travels only in one direction and prevents the current from traveling in the opposite direction. So a rectifier is a device that changes AC, which is alternating current, to direct current, and that is option D. So the correct answer here is D. Moving on to the next question, it says the dimension of Young modulus E is given by dash. So we know that Young modulus E is stress over strain. And because strain is dimensionless, as it's talking about extension and original length, extension over original length, so it is dimensionless. So our stress is force over area, and we know that force is equal to mass times acceleration. So this means that stress is mass times acceleration over area. So which means that my dimension for stress is going to give me mass times my acceleration is length per time square. So I have what? Length per time square over my area here is length square. So this means that I have mass times length times per time square over length times length. So length will cancel out length. This means that I have what? Mass per length per time square. And it also means that if stress is length per mass per length per time square, automatically our Young modulus will also be mass per length per time square, because strain here is dimensionless, which means that the dimension for stress is also the dimension for Young modulus. So looking at our option here, we're looking for the one that has mass per length per time square, and that is option C, mass per length per time square. Moving on, question number 21 says, the moon's acceleration to gravity is 1 over 6. There's a typographical error there. What we have there is 1 over 6. So we have the moon's acceleration to gravity. Moon is 1 over 6 that of the Earth. This is Earth. So, and then it said, the weight of a bowling ball on the moon will be dash. So we know that weight is mass times acceleration to gravity. So this means that since the mass of the object is constant, because mass is constant irrespective of location, This means that the mass is equal to the weight over the acceleration to gravity. So if the weight of an object on Earth is a particular value, they are asking us what to be its weight on the moon. So comparing it to that of the Earth. So how do we do that? We already know that the accelerated gravity of the moon is 1/6 that of the Earth. It means that the weight on Earth is equal to the mass times the accelerated gravity of the Earth, which is what? 10, as in this case. Then the weight on the moon is going to give me the mass times the accelerated gravity of the moon, which is 1/6 times 10, which is the same as saying that the weight on the moon is going to give me the mass times 10/6. So that is to say that the weight on the moon is equal to 1/6 the weight of Earth. 1/6 the weight of Earth, because the weight of Earth is mass times 10, which is mass times 10 divided by 2 here, divided by 6 here, will give me the what? Weight on the moon. So it means that we're looking for an option that has to do with what? 1/6 the weight on Earth. That will be the weight on the moon. So the question is, the weight of a bowling ball on the moon will be dash. So option A says it will be 6 times its weight on the Earth. No. Option B says it will be 1/6. So this is a typographical error. So 1/6 of its weight on the Earth. So the correct answer to that question is to be 1/6 the weight on the Earth. Moving on to question number 22, it says if a sheet of an insulating material is inserted between the plate of an air capacitor, the capacitance will dash. Now, when you insert an insulating material, which is a dielectric material, between the plate of a capacitor, it will increase the capacitance. The capacitance of that particular capacitor will be increased. So the correct option here is option C, which talks about what? An increase in the capacitance as a result of what? Inserting an insulating material between the plates. Moving on to the next question. Question number 23 says 288 kilojoules is conducted across two opposite faces of a 3-meter cube of temperature gradient 90 degrees Celsius per meter in 7,200 seconds. Calculate the thermal conductivity. So we are given the quantity of heat here as 288,000 joules, and then they said that the depth is 3 meters, which is also the same thing as saying that that is the the length or depth is 3 meters. Then it said that the temperature gradient has changed in theta over depth is 90 degrees Celsius per meter. Then it said the time in the question is 7,200 seconds. Calculate the thermal conductivity, K is unknown. So we know that our Q is equals to Ka, change in temperature, T over depth, which is the same as saying that my K is equals to QD over A, area, times change in temperature times time. So this is the same as saying that my thermal conductivity is, my Q here is 288,000 times my D here is 3. So I find my area. Looking at this, you can tell that the area is equals to D raised to power 2, which is the same as saying I have 3 square, and that will give me 9 meter square. So this is all over. My area here is 9 times my temperature. Change in temperature here was not given. So my change in temperature is supposed to give me my temperature gradient times the mass, or times the depth. So this means that I'll be having 90 times 3. This is times my time there is 7,200. So that will give me So if I multiply, I have 288,000 times 3. So that will give me 864,000 divided by 9 times 270 times 7200. That will give me 174,96000. So 864,000. So this will give me that I have 0.0494, which is equivalent to saying that I have 4.9 times 10 raised to power minus 2 watts per meter per Kelvin. So looking at this, we're looking for 4.9 times 10 raised to power minus 2. So our correct answer to this question here is option A, which is 4.9 times 10 raised to power minus 2. Moving on to the next question. Question number 24 says, a sonometer's fundamental note is 50 Hz. So we have our first frequency as 50 Hz. You can try to call this F0. Then it said, what is the new frequency when the tension is 4 times? So what is F1? We do not know. When our T2 is 4 times the original, is 4 times T1. So this means that for us to solve this question, we have to know what relates our tension to our frequency. And our frequency is directly proportional to square root of tension. That is to say that my F is equals to K square root of tension. And that means that my K is equals to frequency over square root of tension. And since I'm having 2 different frequency and 2 different tension, this means that my F0 over square root of T1 is equals to F1 over square root of T2. So this means that what I have here, which is 50 over square root of T1, is equals to F2 or F1, which I do not know, over square root of 4T1, because my F2 is 4 times what I have for my T1. So if I cross multiply, this means that I have 50 square root of 4T1 is equals to F1 times square root of T1. This will give me 50 times 2 times square root of T1 is equals to F1 times square root of T1. So this will cancel this, and I have 100 is equals to F1. So it means that F1 is 100 Hz. So looking at our option, that will give us option B, which is 100 Hz. So we've come to the end of today's class. If you have any question, drop it in the comment section. Don't forget to subscribe and turn on your notification bell so that when we drop more videos like this, you'll be notified. Thank you.